What's up, guys? Welcome to another episode of Science in 5 Minutes or Less. Today we're going to be talking about the rate of dissolving. All right, this week we have 3 videos, so make sure you're watching all of them because it can get kind of complicated. All right, so let's start off with the first thing. First off, if you don't know what dissolving is, it's when you put a substance into a liquid and then it dissolves. Then it kind of blends in with that liquid, right? Like when you put Kool-Aid into water, it dissolves into the water. Okay, se disuelve. Now, there are 3 factors affecting the rate of dissolving. One of those factors is temperature. The hotter it is, the faster that it's going to dissolve for most cases. And the colder it is, the less it's going to dissolve. So if we look at this picture, we have cold versus hot. And you can kind of see in the cold, it's cloudy. There's a lot more. That means it didn't dissolve, right? It didn't mix and separate out into the water. So it's not good at dissolving when the substance is cold, usually. And we can see that in the hot substance, instead of having here, it goes from the cold when we have 10, and then all of a sudden it drops to 5. We have a lot more of the substance actually dissolved in there, and they both have the same amount. It's just that the hot water has more kinetic energy. It's moving more, which causes everything to just separate out into the solution. So that's what's happening. So basically, hotter, more dissolved. That's what you have to remember for that. 2, you have to remember the rate of stirring, right? So it's just, did you stir it or did you not stir it, right? So let's look at the second picture. Stirring a solution speeds up the rate. So whenever you stir, obviously, you're making it go faster, so it's going to dissolve more. That's easy, right? It disperses the solute, the particles, and it makes it contact with all the rest of the particles, and it dissolves, right? Like when you make Kool-Aid, you don't just drop in Kool-Aid and just let it sit. No, you have to stir it, stir the sugar in, and make sure everything's properly and equally spread out. And the last thing that we're going to talk about is the size of the particles. So just picture with me either let's look at the third picture. Picture like just fine salt versus like really thick salt. Which one's going to dissolve faster? Okay. The one that's smaller is going to dissolve faster because it's easier. It's already broken apart. It's easier to dissolve versus the one that's in chunks. It's going to take a while. If you remember that lab we did, we had to take a little thing. We had to crush up all the salt that I gave you. And then that's when you were able to dissolve, or the sugar. That's why. The larger the surface area, so smaller things cover more space, so it has more surface area, the better the dissolving, versus this cube-like, it has less surface area. It's not spread out as much because it's in chunks and it kind of sinks to the bottom. So that's a little bit worse. It's not until you crush that up that it's really, really good at dissolving. Okay, so just a summary of what we did. Hotter, better dissolving. If you actually stir the solution, better dissolving, and the smaller and more spread out the little particles are, the better dissolving. Okay, hopefully that helped. This video is part 1 of part 3 for this week. Good luck.